And that's how the entire hammer mechanism works. Welcome to another episode of the Tool Academy. Listen, as usual, I read through some of the comments. The GISAM brand kept coming up non-stop all the time. On every video, at least one comment about this brand. So I clicked around, ordered them, and here they are in front of me. 4 little packages. Each package will be a separate episode. So we're starting the GISAM series. Let's get started. Listen, in front of us is probably one of the most interesting products from this manufacturer. We'll try to tell you as much as possible about it. Let's start with this device. What do we have here? We'll begin our adventure with GISAM, our review of this brand, with the impact wrench. This is probably the most popular and hottest topic on the internet. As for this wrench itself, its specs look very promising on those Chinese websites. I don't know if there's an official manufacturer website. Honestly, I haven't looked, but if there is, we'll try to include any information the manufacturer provides there. To start, what do we see here? We see packaging that, in my opinion, is somewhat modeled after Makita's. It looks like a MacPack, but it's definitely smaller. Let's open it up. This is what it looks like. It's, shall I say, a bit wobbly. Of course, there's the standard documentation. We'll look through it later. We have the device itself. There's a molded styrofoam insert. We have a battery, just one, with some very interesting markings on the casing. We have a little charger in the form of a power adapter, like for a laptop, only 3 times lighter. It basically weighs nothing. I don't even know if there's anything inside. And a belt clip. Well, the case itself, as cases go, is very flimsy and delicate. But yes, that's what we got. First of all, just to clarify right from the start, we're talking about a device that costs this much money, so let's keep that in mind. And all the parameters that the manufacturer claims and that we will be verifying should also be considered in light of this price. However, price is one thing, but it would be good if these parameters at least somewhat corresponded to this device. The parameters that, I don't know, the manufacturer or seller shows off and boasts about. So maybe let's try to verify them somehow. The key itself, listen, looks honestly pretty solid. It's quite a chunk of a key, it's pretty heavy, this device, made quite sturdily, and the handles are rubberized. I get the impression that it's modeled after Makita. These stickers here are kind of half stuck on. This intermediate housing is made of aluminum. As for the anvil, it's nice and metal. The safety is a ring to keep the sockets from falling off. Manufacturer's sticker. On the other side, we also have a manufacturer's sticker. There are no specifications on this wrench. Here we have some function buttons. Basically, there's one function button and some LEDs. However, there should be some information here which is actually missing. I don't know if something didn't get stuck on here. The device has only 2 pins. There is no safety pin here. There is no temperature sensor here. Just 2 pins, so these batteries, whether original or Makita, we definitely have to watch out for deep discharge because it will drain them to 0. If the battery's electronics don't protect against that, the tool definitely won't either. So what now? And that's basically how it looks, more or less. A little battery. Well, it's an interesting thing. A lithium-ion battery. Of course, we'll take it apart, measure it, and verify it. Here we have information about 598V, probably farads. I read that somewhere on the internet. I have no idea what this is about. We'll try to put some explanation of this abbreviation here soon, what the manufacturer meant. Charging slot. For this power supply, it's located right here. That's how it looks. There's no satisfying click. It doesn't really snap in when you plug it. It just kind of wobbles. But let's keep in mind the price we paid for this device. Let's connect the battery and see if it even spins. Listen, with the key responds. As for the functions, let's try to figure them out. Rotation, right. Three gears, 3 rotational speeds. When it comes to spinning to the left, we have 1 constant rotational speed and 1 intermittent speed. I suspect this is that intelligent impact feature, as professional tool manufacturers boast, where it applies force to break loose and then cuts off. So for example, the bolt doesn't fall into sand or snow. That's more or less how it looks. What else do we have here? We have a rubberized front and we have an LED. It's put together fairly solidly with these 4 Allen screws. The construction, listen, it holds together reasonably well, it's not flimsy, it doesn't feel like it's about to fall apart, so that's good. So as a first impression, for this kind of money, if it actually wants to spin, then that's cool. What else can I say? Let's see what the manufacturer has told us in the manual about this, if there's anything here at all about the specifications. Well, as far as this slip of paper goes, we only have information about the descriptions, what is what. In reality, when it comes to the full specification provided by the manufacturer, we have the following information. Square drive 1/2, input voltage 110 volts to 240 volts, output voltage from 18 volts to 21 volts, motor type, brushless motor, that's it. Listen, well, that's how it looks from the outside. Let's go to the workshop, take it apart and see what's inside. Let's try to compare it to a professional device. Is the construction at least somewhat similar? How did the manufacturer do it here? How did the manufacturer build a professional impact wrench? Let's refer to a professional manufacturer. Let's examine its parameters when it comes to impact. Let's try tightening some wheels. Let's see how it performs in typical workshop and field conditions. And that's everything. Let's go. Listen, when it comes to rotational speed, it's a very similar situation as with the smaller wrench from this brand. Completely exaggerated. I don't know if they're measuring the rotational speed of the rotor or the speed at the spindle. Maybe it really is about the rotor's rotational speed because that's practically 3 times as much. Let's do a test of the actual newtons, see how it looks, and take a look inside. Listen, when it comes to the newton test for these wrenches, we'll include them. In both this and the other episode, actually. One about the bigger one, the other about the smaller one. However, I tried to prepare as best as I could for this test. It cost me a bit, to be honest. Honestly, I bought a device, an adapter for Newton meters. I bought a wrench. It generally has 500 Newton meters. It will come in handy for me somewhere in the future, so that I'm not just investing in a test for a Chinese product. We will try to somehow standardize these tests in the future. But that will be in the next episode, the promised one about fish. We'll talk about the general future plans for the channel. We'll discuss what we intend to do, how we plan to test things, and generally, what's next. The idea behind all of this? Listen, when it comes to the actual test, I watched a very interesting test somewhere on YouTube. The guy prepared really well and tested many wrenches. And based on that, it gave me some ideas, but I thought I'd do it a little differently because with professional wrenches, we basically have 2 parameters provided. The first parameter is the tightening force, and the second parameter is the braking force. Here I have an old DeWalt that has served me well for a long time. It's the DCF 894 model. And in the case of this model has generally already been replaced by the DCF 891 or 892. The only difference here is the grip. However, this particular 894 model has a tightening force of 447 Newton meters and a braking force of 813 Newton meters. I'd like to do 2 tests. The first test will be to try tightening a nut. I have here, I bought it today, an M18 nut with a longer thread so that the thread doesn't get pulled out in class 10.9. We'll tighten it with a torque wrench to, let's say, several different Newton meter values, and then we'll try to loosen it with these wrenches. I suspect they'll handle it without any problem. However, later we'll try tightening the nut with the wrenches. But here's an interesting point because we don't really know how long we need to keep it under impact for the nut to be properly tightened. We'll do a test for 5 seconds and 10 seconds. I am going to hold the nut under impact for a full 5 seconds, and then we'll attempt to loosen it back up with a torque wrench by utilizing this specific digital torque adapter. And we'll see at what point the nut loosens. And we'll see with what force the wrench, both the first and the second one. And we'll also check DeWalt to see with what force these wrenches tighten the nut. So, let's get to the test. Listen, I came up with this kind of setup. Maybe I'll improve it a bit in terms of cleanliness. If you have any other ideas for this, I'd be happy to hear your suggestions in the comments. Feel free to join the discussion below the video. I took a piece of this channel bar. As you can see, I drilled through it, put on a nut, like I mentioned, M18 with a washer, class 10.9, and this is what it looks like. For now, I have securely tightened down the bolt with the nut in an incredibly firm and stable manner. However, you can see that this long nut is still noticeably loose and unstable. Let's carefully tighten it to, say, 500 Newton meters, which is all the way up to the maximum extent that my torquey wrench allows. Later, we'll verify this value to see if it's really 500 Newton meters on the gauge on this attachment. And we'll try to loosen this nut one by one with all the wrenches. Okay, we've set it to 500 Newton meters. I'm going to go ahead and put a small metal nut right here, because earlier on I carefully took the measurements in this exact manner, specifically so that the long socket wouldn't end up going in too deep and wouldn't accidentally catch on to the other nut that is already there. Alright, listen up, let's get to tightening. Okay, we've got 500 Newton meters. Let's check it. So, are the values changing?
No.
Alright, we've got 500. Alright, listen, we definitely have this long nut tightened to 500 Newton meters. I'm setting it to loosen this small GISAM. As for the gear, we'll set it to third, which is the lowest gear. The battery is the original one, the biggest, fully charged. Gear number 3. And we're trying to loosen it. Basically, there's no chance. Alright, let's make sure one more time whether I didn't loosen this nut with the small one. I'll try again to see if it's still 500. Now we're carefully adjusting this wrench to the next gear setting, which is the second one, and we're going to try to loosen it. No chance. Let's check if it's still 500. We're setting it to the highest gear and trying to loosen it. Well, it came off on the third gear. Alright, listen. As for my torque wrench, that was the maximum of its endurance and its capabilities, which is 500 Newton meters. Now we have to manage with this adapter. Let's tighten it to, let's say, 800 Newton meters. Listen, we had to make a slight adjustment because the nut started to turn, the bolt with the nut, the lower one started to rotate. So the welder came into play because these Newton meters are already quite serious. We set the adapter to 1000 Newton meters, tighten the nut with the ratchet to a torque of 1000 if we can, and then try to loosen it with the smaller wrench on the highest setting. 800. Alright, listen, we've got it tightened to 800 Newton meters. I'm afraid to pull any harder because something might give, probably the ratchet. So if we test more of these machines, I'll try to use a bigger bolt with a larger size, maybe M30 for example, or M27 with a finer thread so we can achieve a higher torque. Let's try to loosen the nut, which has been tightened to a torque of 800 N. Highest gear, small GISAM. Well, as you can see, 800 newtons, there's no way it could loosen that. Let's try. It didn't budge. The total count comes to 830. That sounds exactly right to me. As you saw, we had 830. Now we're taking the bigger GISAM. We set it to the first, the slowest gear, the weakest gear. When loosening, well, it will loose to me. When loosening, there's only one gear. One is so that the nut doesn't fall for you. So it doesn't fall into the sand, and the other is full power. So we set this one to full and try to loosen 800 newtons. Damn, when it's hot, I'm really sorry. But the big wrench, which is rated at 1800 Newton meters, couldn't handle the nut that was tightened to 830 Newton meters, as you just saw. As you can see, we just checked 800 Newton meters. We're trying to loosen this nut with the DeWalt. The DeWalt has a breakaway torque of 830, let me check. 813 Newton meters. So that's the breakaway torque listed in the catalog. We've got it set to max. The battery is fully charged. 5. So let's try. I'm sorry, but the DeWalt couldn't handle it either. Let's try hitting it for a moment longer with the big GISAM. No chance. And let's try putting a Makita battery on the big GISAM. I've got a 4 amp hour battery here, fully charged. Sorry, but that's just not possible. Alright, as for the tests, you saw it. 800 Newton meters. Basically, it handled all those cases. Now let's try tightening these bolts. Let's do it this way. And now, so we don't drag the video out like a soap opera, let's do it this way. I'll set the smaller one up. The GISAM to the highest rotation speed, to the highest really. And I'll try for 5 seconds to tighten this nut, and then we'll try to loosen it. We'll see at what Newton meter value it gives in. Now, let's see at what value we can loosen it. Listen, I loosened it at a value of 90 Newton meters. Now we're going with a little GISAM on the highest gear. 10 seconds. Alright, listen. And now we're loosening the Titan nut. "96 Newton meters, so basically time didn't really make much of a difference here. I tightened it, the wrench tightened it to a value of 90 Newton meters. That's all. We have the big GISAM set to the highest torque, the highest speed. We're trying to tighten it for 5 seconds. Alright, now we're loosening it. "162 Newton meters. Now with the big GISAM, we're tightening this nut for 10 seconds. And now we loosen it. "187 Newton meters. Listen, when it comes to DeWalt, let's not stick to 5 seconds. Let's give it 10. This isn't a test. DeWalt's time will come, but for now, let's tighten this nut at the highest speed for 10 seconds and try to loosen it. We'll see at what newtons it will give way. And now we loosen it. So listen, that's the situation. I don't know if I'm doing something wrong or if with a bigger bolt the values would be different. I have no idea. This is the first time I'm doing a test like this. I'll try to do a few more attempts off camera. I'll expand our measuring device a bit more to accommodate larger diameters. And I'll see how that turns out, but as you saw, to sum up this Newton test, we tightened the nut with a torque wrench. The nut was tightened to a value of 500 Newton meters, and all the wrenches managed just fine. However, at 800 Newton meters, none of them were actually able to loosen the nut. When it came to tightening, none of them exceeded 200 Newton meters. Not a single one. So, well, that's what these Chinese NM are like. Listen, this is what the insides of this larger wrench look like. There are a lot of similarities here, only the size has changed a bit. The switch is very similar. The wires for this switch are also very tiny, but, well, I suspect they work with relays. They don't actually carry any power here. That's how it looks. They only activate the controller. A little strap, a terminal for 2 wires, the power unit is very, very similar, also quite rubberized. It's well protected, sealed, I think it's fine. The LED circuit, a single diode. This is what the rotor looks like. The bearings are definitely bigger, 608 RS. On the other side, it's also 608 RS. I see that we can replace them without any problem. As for the brushless motor, it's made using sensorless technology. So it's the more economical version of the motor. Let's see if this copper is actually copper. Exactly, listen, after scratching it. It looks like this time it's not aluminum painted copper color, so that's good. Alright, let's put this aside and take a look at the gearbox. And what do we have here? Here we have a sliding washer. Under this washer, we can see a bearing in the housing, quite a large one. 62.02 is the size. What do we have next? The planetary ring gear. And that's what the entire impact mechanism looks like. Only the anvil is quite big. Nice. Maybe I'll illustrate it with a measurement. Diameter 55 millimeters. Everyone can see how much grease there is. We'll apply some fresh grease. Here we have a sliding washer. Here, under this washer, we have a sliding bushing. It has 2 lubrication grooves here. As for the spindle, in the previous model, we had a sealing ring here. In this model, we don't have it here anymore, but we do have 2 lubrication grooves. That's how it looks. Alright then. The construction of this device is very simple and basic. Let's try to measure the hardness of this spindle. Listen, just take a look at what the inside of the housing looks like. It may not be some super top-notch quality, but there's nothing particularly terrible about it either. You can see that there aren't any major burrs or casting defects here. Here we have something a bit delicate, but nothing disastrous. The other side looks similar. As for this mechanism, both outside and inside, everything is die-cast and CNC machined. Both sides are made quite precisely. There's barely any grease in here. Alright, listen, I'm going to start putting it back together. Listen, the device without the battery weighs almost 2 kilograms. With the smaller battery, it's 2.23 kilograms and almost 2.5 kilograms with the larger one. What do I need to pay attention to? Honestly, it's hard to snap these batteries in here. They're fitted very tightly. I don't know if that's good or bad. It's good because the device has an impact function, and I suspect that soon it will start to loosen up and rattle, just like with the popular red brand. But let's see how the Makita battery fits in here. Well, Makita is also pretty tight, although as you can see, the battery I have is already quite worn out. But that's how it looks. Listen, when it comes to the summary, well, for the money you see here, I bought a device with a 2-year warranty, because that's required by law. I bought a device with a battery, I bought a device with a small case, with a charger that's quite decent power for a ridiculously low price. There's nothing particularly terrible about the build quality either. Of course, the components are just the usual basic ones. What else would you expect? There aren't any glaring inaccuracies here when it comes to the manufacturing of this device. It has a nice rubberized handle. Inside, as you saw, the casing is also pretty decent. Well, I didn't get any stickers. Oh well, I'll just have to imagine what should be written here. So what now? And that's pretty much it, really. So for that kind of money, it's not bad at all. I probably wouldn't take this to a workshop, but you also have to consider the warranty when it comes to workshop use. It's actually quite nice to work with. There's definitely no noticeable difference here, like it's not big, heavy or loud compared to professional devices. So overall, these Chinese products are getting better and better, I have to say. Thank you very much for watching another episode, well, about the brand you requested. So I invite you to watch the next videos. Leave a like, subscribe, boost the videos, it really helps us out, and see you in the next episode.